I was just telling Adam here that I got invited by our very own B.D. Erickson to fly first class to Antigua ASAP and start planning to take the whole island off grid. It's got to be like a, I don't know, $50 million. I mean, we could do the math on the population, but I think there's like 60,000 people live on the island. Yeah. It would basically be like taking all of Missoula off grid. Yeah. So maybe it'd be a good test case. Yeah, go down and see if you can do it there first.
So a lot of those islands are themselves.
Yeah, the storage is an issue. If you're really going to do it, and whether it's compressed air, pumped water, maybe you supplement with some tidal, some wind, maybe just something so you get a little more 24/7. But maybe it's hydrogen, but you got to store some energy. You can't just have the lights go out when the sun goes down. Anyway, okay, so let's take a look at Dr. Swift's materials.
So he's not coming today?
I don't think he is. I've been trying, and I've just if we can get him here, if we can get him here next week, we will. But I'll certainly share his materials with you. They're quite good.
Adam must have put something in the
Grant file?
Just read your post and replied to it. I got started on the section and stuff. Posted it up there.
Okay, so let's just take a look here. So Swift had, look at the quiz. Well, let's just look at the quiz right now. Time value. Time value of money. And this gets back to whether you'd rather have $1 today or $1.10 tomorrow. So your rich uncle has just given you $50,000. You found a long-term investment that earns 6% compounded annually. What will be the total value of the investment at the end of 20 years? So I'm just going to read through these. I'm not going to.
1,000 times 125%?
I'm not going to do the math. So I'm just I don't have. I had the solutions here. Maybe we'll just go through the solutions too. You're considering purchasing 100 shares of stock in Big Money Company. You expect the stock to pay annual dividends of $1,200 at the end of each year and be worth $85,000 at the end of 10 years. When you plan to sell the stock, the investment costs $40,000, and you need an annual return rate of 9.5%. What is the expected net present value of this investment? So net present value takes into account the fact that the money is earning money, but it also takes into account the fact that money is, the same amount of money you have right now is worth less in the future. So the question, it goes back that it's the flip side of that question. Would you rather have $1 today or $1 tomorrow? Well, you'd rather have it today because you could do something with it. If you get the $1 tomorrow, it's not worth as much. Here's the next one. 4 points. Renfree Mines owns the mining rights to a large tract of land in a mountainous area. The tract contains a mineral deposit that the company hopes to mine and sell. It's expected that the cash flows would be associated with the opening. That reads a little bit weird. It is expected the following cash flows would be associated with the opening and operating the mine. So there's your capital investment, $850,000. You have to pay for that now. You're going to get these cash receipts of $227. It's going to cost you road repairs. In 3 years, you're going to have to pay for that. Salvage value in 6 years, so you're going to be able to get back to $210. The mineral deposit will be exhausted after 6 years. So this is Yeah, they are, yeah.
And looks like equals PV.
Yeah, and have you used some of that in
Oh, we did
Excel?
it in energy storage.
Okay, good, okay, all right.
It's really handy, actually.
Yeah, all right. So if you've taken energy storage distribution pricing, have you seen this stuff before at all?
I've seen some of it.
Okay.
Have I used it continually?
Yeah.
Known it?
Right,
No.
yeah. So let's just look at the solutions here.
My first one would be, you get the rate of return for the 1 year times by 20, wouldn't it?
Calculation attached. Well, here's the answer.
With the calculation attached.
Yeah, it might be at the bottom here.
Sure.
Oh, yeah, here's your 50,000, so
You sure it wasn't written out?
there's the calculation right here. Inputs, present value of 50,000, annuity payment 0, number of periods 20, interest rate 0.6, there's a future value. I think I have that spreadsheet, let's just go grab it. In fact, I bet his spreadsheets are even on the website now that I've opened it up. And let's see here, I've got it from 2012. Copy of time value of money. I think it's going to be that time value of money
Because we're
first.
gonna have to do that shortly. Because we've been on our EPA grant.
Uh-huh. So let's look for this one where we've got inputs, so we've got future value at the bottom. Future value. Oh, so these are all kind of, this is like a fancy little spreadsheet that Swift put together. So present value, and let's just go to his solutions. We'll put in $50,000. Annual payments, 0. Number of periods, 20. Interest rate, 0.06. So there's the solution. Now, if we dig into these guys, so these are all just inputs. So yeah, it's pretty simple. I mean, it's just one function, but future value. So what we have is those 4 arguments, and if we, so we can see that here's the rate, there's your interest rate, so you're making 6% per year, N per, that's the number of periods, 20, payments, what's,
Payments are none.
yeah. So yeah, it's not paying you each year, so nothing's coming out of it. And then PV, that's the present value. So we can see that PV is C8, that's the 4th. And then type, I think, and there's no argument there on type. That just must mean compounded. Let's see if we can do a help on this one. FV. Excel functionals. Financial functions. Reference. FV function. Type optional. The number 01 indicates when payments are due. Okay, so 0 is at the end of the period, 1 is at the beginning. So that depends whether or not it's accruing interest over the year or not. Is that clear enough? Yeah. We want to look at the next one. one. Number two, 1,000 shares. The initial investment is 40,000, so we can see right there is negative 40,000. Dividends. Now here's calculation attached. That's what's the sale of stock. Let's see, where's that? So we'll have to look at calculation attached for there. Okay, sale of stock is also 34. So the net present value is, what's that, 1833. So let's go look at this guy. Let me, so does this mean 1833 per share? Is that what I'm, times, 1833 times 100 would be a, no, that doesn't seem right. Each year. It'd be worth 85,000. Investment costs 40, and you need an annual return rate. What's the expected net present value of the investment? This just seems too low to me, right? To have the, if it's going to be 85,000 in 10 years, and
Yeah,
you're,
that one always confused me. It's almost like they take that earned amount and then work it backwards. using
yeah.
Percentages and factoring in all the dividends and what, yeah.
Okay, let's just take a look at it. Yeah, that's always confused me a little bit too. But maybe we can work through it. Let's just check it out. So we already looked at that one. Present value, annuity payment, and then there's going to be the second one too. 35. And that's number 3. Okay, so we have these two numbers to look at. So we already know that it's going to be worth 85,000 at the end. That's the interest rate we just looked at, and here's the number of periods. So this thing is number 1 just in reverse. So if you buy it for $34,298 now, and you're making 9.5%, in 10 years it's going to be 85,000. That one's pretty straightforward. It's just the same problem we just saw in reverse. This one, let's see.
Sure would be nice if you could put money in the bank and get that kind of rate.
Oh God! You know, it's a joke. I'm looking in
You can't
the
get anything.
I'm looking in the paper, and it says we're paying 0.0852%, or you know, so, what the heck? It's bizarre. Hey, Corey. I'm okay. I'm in the middle of lectures. Is it something urgent? Will do. Thanks. All right. Okay, bye. Yeah, so working backward, number of periods. This one, present value calculation. Let's just go do this present value calculation in his little spreadsheet.
That was pretty straightforward, that's why I understood.
Oh, really? Well, let's just make sure we can duplicate it. 0, annuity payment 1,200, right? Number, 100.
Periods 10,
Point.
period of interest.
Okay, so let's look at this thing. So this function is present value. So this guy, C14 is the rate. There's the number of periods. There's the payments. and then C8 is the future value. So,
Well, what's 0.09% of 1,200? 0.09% of 1,200 times 10 plus 1,200.
say again now?
Okay, so it's 0.9 or 0.09.
Yep.
That 500 times 1,200. 114.
$114.
Okay, 114. Now, add that to 1,200. Multiply by 10.
The whole thing, or just that?
Oh, maybe that won't work. Okay. No, that's not gonna come out right. So you got 114 a year.
So I'm looking at this guy, so if we take equals that number divided by 10, it's just $753. I guess what's confusing to me here is that you've got a present value of 7534, and it's got no future value. Is this the one that confuses you too?
Maybe, yeah. What is this?
This is present value. Let's just go look it up really quick.
This is another one of those goes backwards.
Yeah, let's just go look it up. Present value is a future amount of money that has been discounted to reflect its current rate as if it existed today. The present value is always less than or equal to the future value because money has interest earning potential. Okay. Characteristic referred to as the time value of money. So let's go, so if we take this guy, let's just take the interest rate and put it at 0. So that makes sense. So if you're getting 0 interest rate, and you're getting, it's just 10 payments of $1,200 a year, the present value is $1,200.
Okay, so what's 0.9%, 0.95% of 1,200?
Okay, sure. Let's just go back, put the, equals that times that?
No, 12,000, I mean.
Oh, okay.
You're gonna get this,
Equals that times that times that, right? It's that number times 10.
no, because you multiplied 1,200 times 10,
Mm-hmm.
and you got 12,000.
That's right.
Now, 12,000, 0.095% of 12,000 is 7,531.
No, no, it's 1,140. I'll do it again. Equals 0.095 times 12,000. It's about 10%.
Here, it's probably like the rate times the annuity, the amount you subtract from the annuity, and then that gives you your value that if you multiply times 10 might be its present value. Because you're going backwards.
Yeah. What it means is that, what it means is that if you've got $7,534 right now, and you can earn 9.5% on it, that's going to be the same as giving you $1,200 a year. That's exactly what it is. So if you say, gosh, I really need $12,000, you say, well, okay, I'll give you $12,000 over the next 10 years in $1,200 payments. I don't have that money now, but what I do have is $7,534.56, and I've got this other guy over here who's making 9.5 for me on the side, and so that way I can give you your $1,200 each year. That's what it is. And so all you need is 75.34. If the interest rate stinks, you actually need the whole thing. And that's kind of where the economy is right now. Okay, so let's go back to the solution. So that checks out. So if we go back up here, so you're gonna pay. You're going to pay $40,000. You're going to net present value of the investment. So I think what it. It's still not exactly clear to me. Let's go back down to that.
34,000 plus 7 minus 40. 34,000 plus 7,000 minus 40,000 is.
Yeah.
I just still don't know where you got 7,000.
Well, the 7,000. That was the calculation we just looked at, and then the 34 was the other one. I guess what's not clear to me is. How you really is that a plus on the 7,000? Yeah, 7,500. Yeah, that's a weird one. Maybe we can. I'm sure Swift would be happy to answer an email about it.
Can we look at the other one?
I'd have to draw that one out a little bit. And let's just go ahead and look at number 3. That one's going to be even weirder. I'll put it up here, and I think Swift would be happy to answer some questions. I might even have a couple too to send him. So, and then what's the fourth one? Initial rate of return from the investment. Let's revisit number 4. Oh, for problem 3 above, calculate the expected internal rate of return. 16.2%. Let's just look at the solution down here. Annuity payment, interest rate, present value. Inputs. Yeah, this one's a little more complicated. Anyway, guys, I'll just let you dig through those. I should do the same. I think I have this. Let's make sure I've got that spreadsheet on the website. Yeah, it's right here. This is his set of spreadsheets. I don't think his iTunes U lectures are still available, unfortunately. I can email Adam Carroll now and ask him if there's a chance, because I think they were actually pretty pretty well done. Let me shoot that off right now.
Well, I like Robin from his already done work and just plugging numbers in. It'll be simple for us when we start making our budgets.
Who's that? Robin from, yeah, I'm like, who's Robin?
Robin from.
Robin Hood.
Robin, yeah, we're gonna need Robin Hood from the rich and intellect and give to the poor. Us.
Intellectual Robin.
Intellectual
I
Robin.
think you got the wrong Adam
Oh, thanks.
I was like, what the hell is that?
Okay.
It's not from you. Got a couple Looney Tune lectures, but.
Okay, so that's one of his, that's one of his, there's also a tax quiz, so let's just look at the, tax lectures. Okay, answer each of the following questions using Word or Excel. Jack and Jill are married and file jointly. Their taxable income is $80,000. Calculate their 2012 federal tax. Assume instead their taxable income is 60 or 160 instead of 80. Calculate it. Oh, this is a pretty good problem. Assume there's a federal tax incentive for installing energy conservation improvements on homes. Jack can still install 7,000, qualify for the benefit, calculate the federal tax benefit of the incentive deduction for 35. So let's look at that solution. Time value money, tax quiz solution. It's weird, look how social media has just kind of like invaded my shell. Like I try to open this PDF and I have to look at social media first. I gotta wonder if there's a way to turn that off. Okay, so federal tax in, income. So I think what he's doing is, he's got the 80K, here's the standard deductions, here's their bracket, 25%. This number pops out. I don't know exactly where that one's coming from. Let's just see if there's an explanation down here. No, I think that's all we got. We have to go back into the lecture notes to see exactly where these numbers are coming from. If their income doubles, one key thing to note here is that their tax bracket went up, right? They went from 25% up to 28%. That's why, part of the reason why that's more than double.
So we don't have to pay taxes on the grants, do we?
No, we're nonprofit. So here's federal tax incentive for stuff. Well, the taxes we pay are to the university. There's like the grant I just got. It's 43% overhead.
So in other words, you gotta give them half the money you get.
No, it's more like if the grant is for it's more like the university gets extra. I mean, I wasn't going to get it in the first place. I mean, the university's already written into the thing. So I put in there what I need, and then the Fed pays the university that much more to administer it, basically. And every university has their own rate. Okay, so on this guy, you're going to put in a $7,000 system, 35% deduction, so there's 2,400. Then since they're in the this tax bracket, looks like they're being taxed on that as well, so it ends up being a $612 deduction, and a $2,450 tax benefit, or that much of a break on the taxes overall. Let's look at this guy. Tom decides to install solar PV. Installed cost is $16,000. Northwestern Energy offers him a $6,000 rebate. In addition, the system is eligible for 30% federal income. There we go, that's good. So 30% federal income tax under IRC and a state Montana income tax credit of up to $500. Assuming that Tom has sufficient tax liability to take advantage of the credits, what is the net cost of the system after rebates and credits? So he subtracts the $6,000, you subtract the $3,000. Where's the $3,000 coming from, though? Where's the $10,000 coming from?
30%.
Oh, so here's what happens. So it's 30% of the remainder. So the $6,000 gets knocked off to the $16,000, and the 30% gets applied to the remaining 10 for 3, and then the Montana state income tax credits. So basically the $16,000 system is only costing the homeowner $6,500. And from there, what you would do is say, okay, what's my annual energy bill? And let's just say it's $2,000 a year. And if you can knock your monthly utility bill down to $5 a month, that's like $120. So 120 is significantly smaller than 2,000. So this thing would have a 3 to 4 year payback, is the point of this whole thing. Versus if you're at 16,000, we're talking 10-year payback, especially once you start getting the time value of money in there. So 3 to 4 year payback, and like companies like B, he said he sold 200 systems in 2 weeks, just instantly as soon as he got bought out by this company, and they're providing free installation.
What kind of system?
Photovoltaics, just like this one, PV systems for the house. Now, $16,000. If we're at $4 a watt, which is a reasonable installation cost in this economy, $4 a watt. It's about a 4,000 kilowatt system. Or I'm sorry, 4 kilowatt system, 4,000 watt system. That's pretty reasonable. I mean, that's actually double what some people here in Missoula are putting on their houses, and they're getting by just fine. So I've got a buddy, he's got a 2 kilowatt system, maybe 2,500 watt system, and his net metering ends up being 0. So this is even more substantial. And if the Montana codes change and you can actually charge the utility for making them electricity, this becomes even more attractive. But as we've heard, Northwestern Energy is all nervous that they don't have the infrastructure. As soon as the PV goes on, transformers are going to fry and blow and all that, which may or may not be true. In general, I mean, the general things I've been hearing is that it actually reduces that because you've got there's less demand.
There's less loads to.
Yeah. I really think that a lot of these coal companies, they're scared. They're scared that no one's gonna
To make money.
want to buy their dirty crap. Okay, then there's one more up here, problem 3.
Well, if you listen to what Kyla Mackey said, we don't need the coal plant in Montana.
Mm-mm.
We don't need it even online.
To supply Montana with electricity.
To supply Montana
Yeah.
with electricity.
Yeah, we're just pumping it out, and it sounds like California don't want it anymore. You know, they're a big customer. They're like, yeah, keep it. Okay, and the other thing, you guys heard about the Crow Reservation selling their mineral rights, didn't you? Big- Yeah, it was kind of sad. It was weird. I heard, the tribe, the current tribal leader, he said, well, show us something better and we'll do it. And I mean, I think what we have going now with the Blackfeet, this grant I just got with them, we're going to get them 3 wind turbines in the next 3 years to install. It's part of the deal, and enough money to start putting more PV in. And for them, I mean, sure, there's people there like, yeah, give me money, but for them, I think they would much rather exist in a world where render unto Caesar that which is, forget the whole money thing. We don't want to become a slave to the U.S. dollar. We'd much rather be independent, So I think for them, it's much more, can we make our own energy and be independent and get off the dole, the U.S. dollar? Yeah.
Because you just explained it before, the coal company won't allow it, Northwestern Energy won't allow it. If they get off the grid, they're gonna have to basically rip every power line down there and have their own constructed power lines. Because that's what they're paying for. They're paying for the power lines and transmission. They're not paying basically for the power.
It could be. I'm not sure if, yeah, it could be. I'm not sure if
And
Browning's on the Northwestern Energy grid or not.
Well,
because
it's
there's-
not Northwest, that was just the site that I was using.
Yeah.
The company, I mean, it might be Vigilante Electric, who knows?
Right, yeah. Because there are co-ops. There's a lot of co-ops that serve rural customers that are just kind of too far out to be on the
So
main
that's
grid.
basically the co-op, is just purchase that stuff and put the infrastructure in and say, hey, you're gonna pay us to deliver this electricity
Yeah.
to you. We're gonna charge you so much interest rate because we have to recover our fixed costs.
Mm-hmm.
That was in some of the stuff that I put up there.
Yeah.
That made it more desirable to go off on PV because it's just gonna keep raising those prices. Those fixed costs, that's according to scientific papers.
Yeah, no, that's true. That's true. Okay, let's look at this last one here on the taxes. So, Mountain Manufacturing installs a solar PV system on the roof of its building. The installed cost is $225,000. Northwestern Energy offers Mountain a $6,000 rebate for the installation. In addition, the system is eligible. So this is an industrial installation versus the residential one we just looked at. What is the amount of the federal income tax credit for Mountain Manufacturing? So there's the cost. There's times the 0.3, 67.5. And what's this sitting over here? So then you've got your 67.5 minus, or no, so then this one right here is the total cost minus the rebate, minus the savings with the 30%, minus the rebate.
That's a funny thing because, is that right?
Okay, well, here's the credit. What is the cost? Depreciation. Where's this 33,750 come from? Do you guys see where that comes from, the 33,750? No, it's too high. What's this little thing? 6750. What's that?
42.
I think it's times .2 is what it is. Yeah. Because see this right here, it says, he's got this it just looks like times .2, so let's do the calculator. Why does my calculator not work? Come on. Stupid. Accessories. Calculator. Times .2. No, that's not right either. 6750.2. Is it just divided by 2? That's what it is. 67,500 divided by 2 equals. Okay, so that's what that is. Okay, so the question is, why is it divided by 2? Well, eligible for depreciation. There must be just something written into this tax depreciation where you get half of it. They must just say you get half of it. And this one's definitely times .2. Anyway, so guys, sorry Swift isn't here. If you have some questions on it, we'll just email them. I think that's basically the two things that he was showing on this one: time value of money and taxes. I looked at both of them best I could. There's this other lecture too. I'm just going to open that up, but since we're at 10 o'clock here, maybe it's time to move on. So I'll just let you guys look at this one on your own. There might be a few other things in there. Time value of money, we already saw those. Solution to capital budgeting. There's this capital budgeting quiz.
Functions in Excel.
Yeah, they're pretty slick.
Well, it's gonna help when we decide the budget, because we got a week to do that. The budget, now we've gotta figure out why this one jumped in. Should really tell.
It's okay, yeah.